Hi, this is James Sayer, and welcome to episode 29 of The Breakdown. Yes, tonight we're talking about the meaning of life. Yep, it's been a long time coming. We've been working hard trying to wrap our heads around it, and we think we've got it figured out for you. So we want to talk about that tonight. What we're going to do is we're going to talk about the essential elements that we know of that are required for life, that are associated with life. We're also going to talk about the different properties and different observable behaviors of organisms, and in general across all organisms, what are the commonalities, and then focus on what are the commonalities of advanced organisms, and then from all that discuss what might we derive, what might we understand, learn, or know from all these principles about the meaning of life, of existence, of being alive, of living and trying to survive, competing for scarce resources against all other organisms, trying to survive in a very challenging world. What is the meaning of all that? So we're going to talk about all that tonight. If you're watching this by video, you can see I'm not in my usual location. I'm in a motel. I'm in Bend, Oregon. I've been doing some hiking. I've been out here. A lot of great hiking out here. It's incredible mountains. If you ever get a chance, it's a great place. There's mountains everywhere. It's a really a hiker's paradise. I'm a big hiker, so if you're looking for a great place to hike, Bend, Oregon is a wonderful place to visit. Anyway, there's my commercial for Bend, Oregon. I'll be expecting my check from the Chamber of Commerce of Bend within the next week or so. So thank you for that. Anyway, so let's get started talking about life. All right. Let's talk about what are the fundamental characteristics of life. Now we know so far what we've been able to determine, right? All life currently that we're aware of exists on planet Earth. Nowhere else in the universe. We haven't gotten very far into the universe yet. Our space probes, we've had two basically to leave the solar system. So we have not ventured out very far. We have not been able to do, we've been barely able to explore the planets and moons within our solar system, with any kind of thoroughness. So who knows what's even still inside our solar system? We could have life teeming on various planets and moons throughout the solar system. We're just unaware of it. But we haven't detected it yet. So as far as we know, thus far, life only exists on Earth. Nowhere else that we're aware of, right? So that would lead us to think that life is rare, right? Throughout the universe, right? Through the vastness of space, where apparently nothing is alive, or very little. We do know that certain types of microbes and microscopic animals like tardigrades can survive in outer space, which leads us to a reasonable assumption that life probably does exist on other planets. For it to exist in outer space indicates that it adapted to survive in outer space for a reason, because it had been exposed to outer space previously, or to conditions that prepared it to be in outer space. So we don't know if life originated on Earth. We don't know if it landed here from, a meteor from another world and brought microbes on it and then started life from another world. It's completely possible, since we do know microbes and other creatures can survive the intense cold and radiation of space. It seems like if something's going to be that adapted to space, it probably adapted to that a long time ago. So life may have actually come here from elsewhere. We don't know that, but we do know that it is highly adaptive. Right? There's 87 different million species of plants and animals on planet Earth. Okay, so that gives you some idea of the incredible variety of life that exists on this planet. That, to steal a line from Jurassic Park, Jeff Goldblum's line, that life finds a way. That it It is so adaptive and so insistent on surviving, so determined to continue to live, to carry on, that it will adapt and change into all these various forms of different organisms of completely different orientations over time to give us, over the course of about 3.7 billion years, that's how long life has been on this earth, that we know. We have confirmed now that there were microbes on this planet, microscopic organisms that were alive 3.7 billion years ago on this planet. Perhaps earlier than that, but we do know that it goes back that far. And that's a very long time, right? I mean, the planet's not that old itself, only 4.5 billion years old. And so for a good portion of that early part, it was, in total commotion. So life couldn't possibly have existed in the early days, but established itself pretty early on in Earth's history. So not only is it adaptive, but it's adaptive, and it's versatile, and it's determined throughout all the different species on this planet, whether you're talking about animals or complex or simple organisms. Life is determined to go on and to continue to survive and to overcome. And we see this demonstrated across the animal kingdom. Like I said before, all organisms carry DNA. That is a fundamental thing. We all have a genetic code, no matter how simple or complex we are, that carries our genetic makeup within ourselves, and then passes that to the next generation. And then that DNA adapts, evolves over time, adapts to the environment for our benefit, for our survival. Now, we're going to talk about the 7 generally accepted, and that there's not universal acceptance on this. This is not to be considered a comprehensive list, but this is a list of 7 characteristics that are widely accepted to be the main characteristics of life. That it's organized, it has complex organization, whether that be a single cell organism or a human being, that it has complex parts and components to it. It has a metabolism, which means that it relies on a combination of different biochemical reactions for it to do everything it needs to do. The sum total of all those biochemical reactions is the metabolism of that creature. Creature has to have a metabolism to survive. Homeostasis is another one. That means the organism has to be able to regulate its internal environment. Like, you have to be able to maintain your body's temperature and things like that. You have to have a metabolism to be able to do that. You also have to grow. Everything that's living grows, right? Its cells divide and grow and increase. It gets larger as it matures. They reproduce either asexually or sexually. If it's asexual, like certain animals or bacteria, if it's bacteria, it'll just split in two, just clone itself right there, and make basically just a clone of itself, a genetic copy of itself, just like that. Asexual reproduction. With humans or other creatures, it's sexual. You have a male and female, and you have the egg and sperm form of reproduction, right? That carries the genetic code from the two partners to the offspring, right? You get half the genetic code from one parent, half from the other, and that creates the next generation. So that's reproduction. Also, response to stimuli. If you're alive, you respond to stimuli. It doesn't matter whether you're a microbe or a human or a squirrel or whatever. If something is painful to you, if something's dangerous to you, you have what's called irritability. There's an instinctual reaction built into your DNA, built into your response to recoil from something that's harmful to you. And they call that irritability. But that's your instinctual response to stimuli. So you may actually lurch forward for something that you really like or want or crave, right? That you feel or perceive will be good for you, or nutritious or delicious or whatever, beneficial in some sense. Or you may recoil if you feel it's a danger, right? But that's ingrained, it's built in, and all living organisms have that for the purposes, of survival. We that's its primary function. We're not speculating about some designer or God creating this, but what is the function that these traits? What is the function that these traits serve? And that is the function that irritability serves, or that response to stimuli. It is a protective function. If you don't respond to things, you're not gonna be able to protect yourself, right, against danger. You're not gonna be able to go after the things, right, that you want to go after, because you're not going to know when to respond to that stimuli. So you have to have that irritability, that response to stimuli, simply to be able to function and get along in the world. And that's true for all animals. Evolution. This is also true for all animals that are in existence. They all evolve. Doesn't matter whether you're bacteria, whether you're fungi, whether you're a squirrel, a horse, a human. We all evolve. We all adapt over time. Our genes adapt, they change, right? And we know that, and the generally accepted understanding of evolution has been that it is a slow process. It is a very, very, very gradual process that can take sometimes hundreds of thousands of generations for a major genetic change to occur, an evolutionary change to occur. But we've seen in a number of animals that's not necessarily true. There are a number of animals, whether you're talking about different types of birds or lizards, or other animals, moths and other insects, that can adapt very quickly, that have adapted very quickly, evolved very quickly to their changes, drastic changes in their environment, within a matter of a few generations. To drastically alter, like, their height, their size, their weight, different things. That in many cases, if nature, if the environment puts the pressure on the creature, on the organism, that the genetic code of that organism responds to that intense environmental stimulus in a way to accelerate the evolutionary process. It can be kickstarted. We don't know exactly how that works, but we have seen it play out in a number of different species that are able to adapt very quickly to their environment as a necessity to survive. So evolution is a core component of is the seventh of the seven generally accepted characteristics of life. So that's just kind of a quick overview of those. Now, we do also say that all organisms die. All right. No, and this is what makes evolution possible. There's no organism in existence that doesn't, age. Its cells degrade and diminish, and it dies over time. There is no organism that lives forever. There is some type of built-in DNA clock that says your days are numbered, that you will not be permitted to exist forever. The function of that is essentially to make way for the tribe, make way for the new generation, right? That your function, your time to live is now for a certain amount of time. Then once you reproduce, then it's time at a certain, then you have to raise your offspring to a certain point, protect them so that they can survive, right? And procreate and create the next generation. Once that's done, once you've got the new generation up and ready to go, it's time for you to go. It's time for you to get out of the way. That's what the lesson of evolution, DNA, and cellular degeneration in all living organisms seems to be teaching us, is that you're not supposed to live forever. You are supposed to die. You are supposed to perish. Your purpose of dying is to make way for the new version of you, the new version of your version of life. Ostensibly, perhaps a new and improved version, right? Arguably, if you're adapting all the time, right, then arguably the next generation is better. The next generation is more adapted, right? That's not necessarily true. We do see sometimes that species hit an evolutionary dead end where evolution didn't play out to the advantage of that species. And we've seen Neanderthals are gone, the Denisovans are gone. Those were two human species that existed at the same time that we did, Homo sapiens. And, we know that Neanderthals died out about 30 or 40,000 years ago. We know that Denisovans were alive around the same time, or essentially a sister species of Neanderthals. So, and it's fact, we know this, and we know from their DNA, we've recovered DNA from both Denisovans and Neanderthals, that if you weren't born in Africa, you probably have some Neanderthal DNA in you. And if most of your ancestors are from Europe, you probably have more Neanderthal genes than most, perhaps up to 2 to 3%. Likewise, with a lot of people from Southeast Asia, where a lot of the Denisovan remains have been found, there are a lot of people in Southeast Asia who have 2 to 3% of Denisovan DNA, and some people who have bits of both. So we carry these earlier versions of human within us still. They are still a part of us, even though they're extinct. We do carry some of their genes on as Homo sapiens. And so some of their genetic code is still with us now, of the Neanderthals and the Denisovans from tens and hundreds of thousands of years ago. That is part of the evolutionary process. So it didn't work out. There are dead ends. Here's another one. Just as an example of a genetic dead end, think of the mule. A mule is made when you have a female horse and a male donkey mate, and you have a mule. That mule cannot reproduce. All right, so that is, a mule can be great for a lot of things, but it's a genetic dead end. It's not moving forward. It's not going to reproduce and be able to further the evolutionary process. That line is not going any further. It's an evolutionary dead end. So we know that evolution doesn't always play out to the benefit of the organism. And we see that too with genetic mutations in all kinds of different animals, including humans, where a child or a baby is born and it's completely, sometimes almost unable to function. Sometimes they die before at birth, or they live, but they have, a very difficult life. So it's not what happened. That genetic mutation is not adaptive, that it is an evolutionary process that has gone haywire. So the evolutionary process itself is imperfect. And it appears our evolution, it is one of these characteristics of life, and that life appears to be trying to work this out. Through this evolutionary process, this gradual adaptation. But we do see that this process of adaptation is imperfect. Mistakes are made. Cells don't replicate perfectly. Sometimes they mutate in ways that are incredibly harmful and not adaptive, and it backfires. So we can say, and this might anger some people, but that nature does make mistakes. We don't know why it does, but it does. Cells do not always do what they're supposed to do. And we don't know why that is. We don't know why, there's a lot of mysteries about where genetic mutations come from, and why that happens. And we know, that there are a lot of different factors that can play into like all different kinds of mutations and things, right? That's just part of life. It's an interaction of so many different factors that sometimes it's very difficult to isolate what is the specific cause of this mutation or this adaptation. But we do know that sometimes the results of those adaptations are not optimal. So it is kind of there, almost an experimental process at work in some ways. Now, like I said, there's all wide range of different organisms, right, from simple single-celled organisms all the way up to us. Advanced organisms. Let's talk about that for a minute. Advanced organisms demonstrate some very, very interesting behaviors, various levels of consciousness, capacity for reason, not just humans, but there are a lot of other animals that can work problems out too, not necessarily as well as we do. Some humans have a real problem with that too. But that we've seen, whether it's monkeys, various types of apes, or even birds, even fish, various types of insects, including ants and bees, are able to solve problems, right? That they're able to solve somewhat complex problems, and use a form of reason to solve those problems. So what we're asserting here is that reason is not a human invention. We've given it a name, but it is a process for solving problems, to adapt, to survive and to thrive, and to move forward. And that we have a human version of reason that we use for our own adaptive purposes, but animals do too. And the more advanced animal you are, the higher level of consciousness you have, the more that you are aware of your own experience and the external world's impact on your internal experience. And that the more aware you are, the more conscious you are, the greater the capacity for reason, the greater capacity to solve problems and to ask, well, if this, then what? Then why? How does this occur? Right? What are the steps that make this happen? What is the evidence that underlies this conclusion? What do I need to do to solve this problem? What strategies do I need to execute, right, to get the result I want that's going to benefit me and my offspring and my tribe, right? And the better I am at executing those strategies, the more advanced I am, the more conscious I am of those strategies, the more adaptive I will be. And we see that in advanced animal societies, especially in mammals, and it's widely accepted that social animals are the most adaptable. The more social the animal, the more adaptable, because you can accomplish so much more as a group than you can just by yourself, right? That if you're part of a tribe or part of a pack, you can work together and you can share resources. Now that opens up a whole new brand of problems. True, if you're part of a group, there's group conflict and politics. You can see that even in the animal kingdom with the animal hierarchies within all kinds of different types of species, right? And all types of different social organizations, social hierarchies, social rules within these groups of different animals that have their own rules, essentially their own type of morality, derived basically from nature as a means to benefit the long-term health of the tribe. And so we can see that the more advanced the animals are, the higher the capacity for reason, the higher capacity for cooperation, right? Like I said before, we're all competing against each other for resources. It is a world at war. That's why life is so hard. We're all scrapping for limited resources. There's only so much to go around, right? That is a fundamental aspect of life, is that limited resources, right? With all these different organisms competing against each other to feed, right? We all have to feed off each other. Organic life must feed off organic life, right? If you don't want to eat organic life, too bad. You got to, if you want to survive. You got to eat something. Even if you don't want to eat meat, you got to eat a plant. You have to eat organic life to survive. Organic life must consume organic life. There's conflict built into the struggle, inextricably, inescapably there. I must consume organic life. All life must consume organic life, right? There's bacteria on all of us right now consuming us, right? Right? I mean, we feed on all kinds of stuff. Um, if you go out in the ocean and you get unlucky with a shark, which is very rare, or if you go out in the mountains, get attacked by a bear or a cat, which is also very rare, then, you're no longer at the top of the food chain, right? Generally we get comfortable being at the top of the food chain, but we're not necessarily always at the top. Really, if you ask me, in my opinion, who's really running the show on this planet is bacteria and like single-celled organisms, because they were here first and they'll be the last to go. They were here 3.7 billion years ago. All right. And they will be here up until the sun incinerates this planet in another approximately 5 billion years, roughly. That's what they think. They think we're about halfway. Scientists, astronomers think that, it's roughly a 10 billion year cycle for our planet, for our sun, and we're about halfway through it. So we've got about 5 more billion years to go on this planet before life is completely terminated by the sun. Until then, bacteria is going to be charging rent. They're running the show. It's them all the way. It's their place. We're just visiting. Yep, that's it. It's true. It's their town. They are like the Marines of Earth. First in, last out. So that's my ode to bacteria. As disgusting as that might sound to some of you. But also we talk about competition, right? The intense competition to survive between all the animals for resources. But we also see in animals a tremendous capacity for cooperation, especially among more advanced animals. I mean, we see it in some pretty basic animals. We can see it in what we think are basic animals like fish. But we see cooperative behavior even between fish. We see it with birds. We see it with insects. And then even far more advanced versions of cooperation in mammals, and especially humans, right? Even more complex social rules, diverse cultures, just way more nuanced. And so, but we see that with that cooperation comes with the with being part of the group, right? Not working together. Cooperation isn't possible without reciprocity. Animals cooperate together based on the knowledge that they know, I'm going to help you if you help me. If I help you and you don't help me, I'm not going to help you again. Right? A wolf isn't going to help another wolf. That wolf isn't going to help him next time. If he knows he's going to help him, and it's a waste because that wolf is not going to reciprocate. So we see this in the animal kingdom, a principle of reciprocity. It's most obviously in mammals, whether they be elephants or squirrels, marmots. Yeah, you see cooperation. You see sacrifice, altruism. You see animals sacrifice themselves for other animals. Other animals sacrifice food for another animal. So these are not just the ideas of cooperation, of fairness, of reciprocity, of reason. While different and at a different level for these different types of creatures, they do exist. It is a myth to think that animals do not use some form of reason. They face problems in life too, which they must overcome daily. And they use a form of reason to solve the problems that they must face. Right now, it's a smaller, much simpler form of reason, but they do have to work out problems, and they couldn't do that without a certain, brain capacity for reasoning and working out those problems, right? That we know that other animals experience pain and are aware, and there's a lot of debate about which animals are self-aware. We know there's quite a few that are. We think there may be a lot more that are as well. Regardless of which animals you choose to believe are self-aware and which aren't, we know that there are other animals that are self-aware, meaning the test for self-awareness is you look in the mirror and you can identify that it's you. You know it's you. You have what that means essentially is you have the ability to determine, to distinguish yourself from another entity, that you have the awareness of your own existence high enough at a certain level that you can differentiate yourself from another, whatever version of you are, right? Another human or another fish or whatever. You can distinguish yourself from that. Now, there are a number of scientists who think that mirror test is arbitrary and is outdated and is virtually meaningless. And I think they may have a point. We're not gonna make a claim on that one. But there does seem to be an argument here. There are a number of people who have made the argument that it is impossible not to be aware of others and be able to function, right? To be able to hunt. You must know that you are hunting prey, right? That you have an awareness you are hunting prey. We have assumed they're not aware. Because we can't tell they're aware, because they're not going to respond to a mirror, because they don't have a brain that's adapted to look at a mirror. But they do have a brain that's adapted to solve problems with a form of reason that is appropriate for their level of existence. So anyway, what we're getting at here is that there is cooperation, but there's also compassion. There's also altruism, the willingness to sacrifice yourself. And not all animals exhibit this. Not all individuals in any species exhibit this. But we do see this exhibited across a number of different species. And some scientists claim that altruism has the benefit of, even though you would think that is not an adaptive strategy, right? If you're going to sacrifice yourself for the group or the tribe, it's not adaptive. If you don't carry your genes forward, then that is not an adaptive strategy for your genes, because they're not going to move forward if you get killed. Now, it could be adaptive for the tribe in that you sacrifice your genes and the other genes of the tribe continue on. So it could be adaptive for the group, but not for the individual. And the individual sacrifices their own, their own line, their own future genetic line, sacrifices theirs for the sake of the other groups. Now, some scientists believe that it's an adaptive strategy in that, like when you there was an experiment with bats sharing food. Right. And the reason that they believe that it's an adaptive strategy for these bats to share food, even though they would think it's not typically adaptive, is that, right, like in this experiment, there were bats sharing food with other bats who came back empty. Like some bats, came back with a lot of food. Some didn't. Some lost out. But the ones with food shared that food. And so while in the immediate, you might be led to think, well, that's not an adaptive strategy at all. But what they observe is that if you give up your food, if the bat gives up a little bit of food this time, next time, if I come back, like I did well this time from the hunt, but if I come back short next time, somebody's going to feed me. That's the reciprocity, right? If I look out for you, you're going to look out for me. It's that cooperation, that agreement, that sense of fairness, which underpins, get ready, morality. Okay, right and wrong, which we cannot conceive of without reason. Reason and right and wrong, morality, are inextricably linked. Now, that doesn't mean just because you have the capacity to reason that you're moral. That means you have the capacity to choose what is right, what is good. And when we speak about what is right is what is good, we're not talking about that in a religious sense. We're talking about being able to make a choice between a good choice and a bad choice, right? And all the different gradations in between, right? So much of life is a gray area where it's not really clear, and it's not necessarily all good or all bad. It's a little bit of good and a little bit of bad, and it's a mixed bag. And you've got to make these nuanced judgments about, should I do this? And if I do it, should I do it in what way? I have to execute it just the right way for it to work. Otherwise it's a disaster, right? So the more nuanced, right? The more complicated, the more complex, the harder the choice, the more demanding of reason, right? So what we were deriving from this is that simple animals have simple social systems. They have a simple ability, the simpler you are, the lower your ability to reason, right? Not all animals are conscious. I mean, we don't think so, right? From what we know, as far as we can tell, bacteria are not aware of their existence. They are not aware. Or sponges, they don't have a brain. Or jellyfish, they don't have a brain either. They are not aware in any sense at all that they're alive. That we can tell, right? I mean, they may sense, they have a bunch of sensors, cells that sense things, but there's no brain there to consciously perceive of their experience. But we know there are a lot of other animals that do, right? That they perceive, they feel, they think, they solve problems, they love, they feel compassion, right? They love their friends, they love their offspring, they feel compassion, they share, they have standards of fairness, they have rules of conduct for their tribes. The primary differences are those of complexity, right? And so our rules, we're one of the more complex organisms on the planet, are more complex, right? Our moral codes are more complex. There's more complexity to our sense of reciprocity and our sense of fairness, right? But they still exist. They exist in humans, but they exist in other animals as well. So these are fundamental principles of life. Now, we've talked about how life fights so hard, right, to find a way, right? Very determined, right? That it's struggled through 3.7 billion years on this planet, and it's branched out in 87 billion different species on this planet. But we also know, some organisms, some animals commit suicide, and most obviously with humans. And I'll use the United States for an example. In 2019, we had 47,500 people in the United States kill themselves, commit suicide, which has been on a very big increase, we'll say a massive increase, over the last 20 years or so. Between 1999 and 2019, there was a 33% increase in suicides in the United States. Now, if you're looking for a red flag that there's a problem with our country, that's it right there. A 33% increase in suicides in the United States in the past 20 years. So if you're looking for an indicator that things are wrong, really wrong, look no further. That's it. And so that percentage, 47,500 people in 2019, that's about 1.6% approximately of the U.S. population decided and succeeded in committing suicide in 2019. Now, there's a lot of reasons why people commit suicide, and there's a lot of factors that go into it. One of the biggest ones is depression. But there are a lot of other factors, too, which could include your actual physical health. Some people choose to end their lives just because they're in so much physical pain they can't take it anymore. But there could also be other things, financial problems, personal problems, even intense professional problems have brought some people to commit suicide. So there's a lot of different reasons. But one of the most common factors involved across all of those reasons or contributing factors to suicide is a sense of hopelessness, regardless of what contributing reasons you have for wanting to take your own life. That is, these people, feel a sense of hopelessness. There's no escape. There's nothing they can do, no matter what. It's not going to get any better. Whether it's the physical pain, or whether it's being bullied at school, or whether it's depression, or whatever those reasons are, it's the sense that there's no escape. That is almost the universal thing that you can find when you look at suicide across the board. That is one of the most common things that you see, is that sense of intense and pervasive hopelessness, and the feeling that there is no escape from it. And so there is a small percentage of people, like I said, 1.6% in 2019 took their own lives in the United States. Now, that sounds like a small number of people, right? I mean, 98%, didn't take their lives. That's good. But 1.6%, that is a chunk. That's a big chunk of people that choose to opt out of life. And we know that it's a leading cause of death in the United States. So it's the second leading cause of death for people ages 10 to 34. The fourth leading cause of death in the United States for people ages 35 to 44. And the fifth leading cause of death for people 45 to 54. And probably don't, it's, probably lower for older folks, because you don't need to kill yourself. Nature's going to take care of that here pretty quick, right? But we've seen that in recent years, there's been a huge jump in suicide rates, particularly for the young, but also for white men as well. And like I said, it was a 33% increase from 99 to 2019. So this is a clear indication that we've got some very serious societal problems, right, that are having a major impact on people's sense of hopelessness. They're so hopeless that they're willing to take their own lives to escape that hopelessness. They're willing to override the strong drive of life to survive and adapt. They're willing to override that and end their life, because that sense of hopelessness is so powerful. So that is, we've noticed that in other animals. Obviously, lemmings is a good example. Scientists aren't sure if lemmings commit suicide, if it's really a conscious choice to kill themselves, or if it's just more of a reaction to overpopulation, right? So we don't know, and we've seen what appears to be suicide in other animals too. But it's difficult for us to, it's hard for us to say, is that animal really taking its own life intentionally, or is that just reckless behavior? Not a particularly smart animal, or, sometimes we just make reckless choices. We don't intend to do ourselves in, we just do it by accident. So it's hard for us to speculate on what other animals are thinking when they take their own lives, but we know they do it. We don't know why. But we know with humans, we know they do it primarily out of a sense of hopelessness, that they're unable to adapt to their environment, right? For whatever reason, they're unable to adapt and thrive, right? They can't find a way to adapt, to thrive, and to survive, right? In a way that is not miserable. So they choose their only way out, which is suicide. And so obviously there's a lot they're learning about, the human brain and that brain chemistry, and that, a lot of depression is chemically produced. And so hopefully medication will address a lot of these cases, but it won't address all of them, because we know there are other causes besides depression. And we know we have a big problem in this country because of this massive increase. And it's definitely something that we need to pay attention to. Big time. So we're getting here near the end. I'm sure you're relieved to hear that. So what can we derive from all of this, from all of these ramblings? What can we take from all that we've just discussed? All the different factors and elements of life. What does all this mean? What can we know and actually derive from what we know? Well, we can see that life has given us a mandate. It has given us a mandate to survive and to adapt and to thrive. But also, like I said, life is hard. So hard that some people choose to opt out. There is a built-in, life is imperfect. Not just in that it's a big pain in the butt and we all have to compete against each other all the time. And even our cooperation is challenging and stressful. All the great cooperation that we do to be that much more adaptive, right? And that much more successful, is a lot more difficult and challenging and stressful, right? It comes with its own difficulties. The cooperation side can be difficult. It sounds good. Cooperation sounds good, but it can be difficult. Compassion sounds good, but being compassionate can be difficult, right? It's not always easy to be compassionate with others, is it? No, it's not. It's a challenge. But compassion, negotiating with others, that the reciprocity, the sense of fairness, these are not easy things to do, right? And in the short run, it may be easier not to do them, but in the long run, they benefit you, they benefit the tribe, and they benefit future generations. And that is the basis for morality. And that is the basis for what is right and wrong. In the animal kingdom and for humanity is what benefits yourself, members of your tribe, and future generations, right? And you use that, your ability, your God-given or universe-given ability for reason to do that. That is your primary tool to determine what is right and what is wrong, right? And that compassion is a highly effective tool that is used by advanced creatures to survive. They show compassion for each other and help get each other through. And it's easier to survive with a group that shows compassion to one another than it is to survive on your own. And groups are not going to stay together if they don't show compassion, if they don't show fairness, if they don't show that sense of reciprocity to one another, they will not cooperate and groups will not survive. So we can know from this that there are that reciprocity, fairness, reason, these all underpin morality. And that morality is real. It's objective. Now, it's objective in the sense that you can determine, right, through principles, what is the right course. It's subjective in that you're making the personal judgment. There's a lot of judgments and assumptions that you're making that are dependent on you, on your subjective experience, right? Remove your subjectivity, though, from that, and there are certain principles that are objectively true regardless, right? That no one's going to work with you if you don't reciprocate. If they give you something, you need to return something of approximate value. If you don't, they're not going to reciprocate the next time. That's just basic fairness, right? Nobody's going to help you if you don't help them in kind. And we see that in the animal kingdom. We also see that throughout humanity. All right. So we also learned that there's, for whatever reason, there's imperfection. Imperfection is guaranteed. Your pursuit in life of perfection is a waste of time. Okay. Now it's the pursuit to adapt and thrive is good. The pursuit to grow, the pursuit to learn is all to adapt and thrive and move forward, right? Protect yourself, the tribe, and future generations, all for that purpose. Even if you're not aware of it, that is the function. That is the function of evolution. That is the function of reason. That is the function of cooperation. That is the function of negotiation. That's the function of reciprocity. That's the function of fairness. And ultimately, that too is the function of morality. These are all inextricably linked. They cannot be separated. Now they're different. They're not all the same, but they're linked. They're connected. Evolution, reason, compassion, reciprocity, fairness, morality. They are all connected, whether an animal or a human. Now, like I said, life really wants to find a way, right? Very determined, right? And we believe, probably, most likely, that there is life throughout the universe. Seems unreasonable that it would only exist here. And since we know that there are certain life forms that are already adapted to survive in outer space, it's a reasonable assumption that they've already been there. Now, we don't know that, but it's very, very likely that in this gigantic universe, life exists elsewhere besides just planet Earth. But we've yet to prove that. We shall see. We're still, really, really in the dark about so much. We've talked about a lot of that we know, but we don't know what the origins of life are. We don't know. We know it at least goes back 3.7 billion years, but we don't know what caused that. Did it come on a meteor? Was it a combination of all these different factors in that primordial soup? It was like the evolutionary, version of the peanut butter and chocolate crashing into together and making the perfect snack. It was kind of like that with life. It was just like the random crash of these different elements at one time and created life. Okay, maybe, but why? Why those elements? Why would those? We have no idea. We have no idea. We have no clue. Whether it started here, came from somewhere else, was it an accident? Was it bioengineered by another species? We have no idea. But we know it goes back a long time, and we know it's complex, and we know it adapts and evolves. We're clueless about the origins of life. We know very little just about even understanding consciousness. Consciousness, or what it means, or how it arises. We don't even know. We haven't even yet determined what is that missing link between the primitive humans that existed before us and the ape family that they came from. Right? At some point, right? We're part of the ape family right now. We are, but our ancestors came down from the trees somewhere between 6 to 10 million years ago. Right? They know that from this fossil record, but they don't know what that species was. They know what came after, but they don't know what that species of earliest human that came down from the tree 6 to 10 million years ago. Completely clueless. They have no idea. We have no idea about the origins of the universe, right? We know about the Big Bang, but we don't know why. Or where did that come from? What happened before the Big Bang? You ask so many questions, you get to a point where you don't know. So we're clueless about the origins of so many of these things. And we've only really had a grasp of any kind of serious grasp of, rigorous scientific understanding for maybe 400 or 500 years, not very long. And like a really, a serious technological use of technology, aggressive use of technology and pursuing that, maybe 100 years, even less, really. So we're just beginning to scratch the surface of understanding the existence of life, the existence of consciousness, the origins of life, the origins of the universe. We're just beginning. But already, from what we know, we can already derive so much. So, I'm going to wrap it up for you. This is my conclusion. All right? This is what I'm here to say. The bottom line is you are mandated, and I've said this before, you are mandated by life, by nature, by the universe, by God, to overcome and to adapt to the struggle of life, to survive in a fair, compassionate, well-reasoned, and moral way. For yourself, for your tribe, and for future generations. That is the meaning of life. Well, that's it for this episode of The Breakdown. I hope that was enlightening. I hope it's giving you something to think about. It's given me a lot to think about. And anyway, that's episode 29 is in the can. Episode 30 will be titled What Might Be. And what that's going to be about is looking at the possibilities that humanity faces currently. And we're going to look at the positive and negative possibilities, positive and negative alternatives. Well, how bad could it get? How good could it get? And what are our options kind of in between, right? Are we going to make it? What are our chances of humanity surviving over the next century? What are our chances of thriving, continuing humanity for thousands of years, perhaps longer, tens of thousands, until we evolve into another species, maybe hundreds of thousands of years from now, if we continue to survive? That's what would happen in time. We're going to talk all about that, the different possibilities of how humanity might go, where we might take ourselves, and what we should do about that. So I hope this was an interesting show for you. I look forward to our next conversation. Take care of yourselves and take care of each other. Until then, bye.